Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all students. My name is Dr. Nurul Hidayah binti Salamun, and today we will move on to our last chapter in our syllabus, which is electrochemistry. So for this chapter, I will be paired with Dr. Siti Aminah. For my part, I will cover several topics, which are balancing oxidation and reduction potential, voltaic or galvanic cell, standard reduction potential, and the last one, the Nernst equation. So for this subtopic, which is balancing oxidation reduction potential, you should be able to define what is electrochemistry and a number of important associated terms. Second, to split oxidation reduction reaction into their oxidation half reaction and reduction half reaction. Third, to produce balanced oxidation reduction equation for reaction in acidic or basic solution. And lastly, to identify which one is oxidizing agent and reducing agent. Okay, so actually, what is electrochemistry? Electrochemistry is the study of the relationship between electrical and chemical energy. It deals with chemical reaction that produce electricity and the changes associated with the passage of electrical current through matter. The reaction involves electron transfer, so they are called as oxidation reduction or redox reaction. So the easiest way to determine whether the process undergo oxidation or reduction is just by looking at the oxidation number changes. So after this, I will be abbreviate oxidation number as ON. So oxidation is the process of losing electron or the increase of ON, while reduction is the process of gaining electron or the reduction of ON. So for example, we consider this reaction. In this reaction, magnesium is reacted with 2H plus to produce Mg2 plus plus H2. Here, we look on the oxidation number or ON changes on each half reaction. So for Mg, the ON change from 0 to plus 2. So since magnesium is a neutral atom, the ON is 0. So when ON is increased, this is an oxidation process. As for hydrogen, the ON change from plus 1 to 0. So this shows that the ON decrease, therefore this is a reduction process. We can also say that magnesium is oxidized to Mg2 plus, while H plus is reduced to H2. Oxidizing and reducing agent are key terms used in describing the reactant in redox reaction that transfer electron between reactant to form product. In this slide, we discuss what defines an oxidizing or reducing agent and how to determine an oxidizing and reducing agent in a chemical reaction. Oxidizing agent is a species that cause the oxidation of another species while itself being reduced in an oxidation-reduction reaction. While reducing agent is a species that cause the reduction of another species while itself being oxidized in an oxidation-reduction reaction. So let's say if the oxidation number is less or decreased, meaning it gained electron and was reduced. So the substance that is reduced in a reaction we can call as the oxidizing agent because it gained electron. Conversely, the substance that is oxidized in a reaction is the reducing agent because it loses electron. So basically, we can say that if it is a reduction process, then the substance that being reduced is an oxidizing agent, while in oxidation process, the substance that being oxidized is called the reducing agent. So here we look at the example. 2H plus accept or gain 2 electrons to produce H2. So in terms of electron, it gain electron. In terms of oxidation number, the ON decrease. So meaning that this is a reduction process and H plus is an oxidizing agent. Another example, Mg will release 2 electrons to form Mg2 plus. So in terms of electron, it loses 2 electrons, while in terms of ON, the ON increase from 0 to plus 2. So this indicates that this is an oxidation process and Mg is actually a reducing agent. A redox reaction can be broken into two half reactions. Take from previous example, oxidation half reaction is when it loses electron in the reaction and the oxidation number is increased, while another half reaction is the reduction half reaction where the oxidation number decreases and it gains electron. So this is an example on how we write oxidation half reaction and reduction half reaction.